Before we start coding the function itself, it's helpful to create a test string. I'm going to call that text, and I'll just copy paste the short string that I wrote previously. The purpose behind having a text string like this is to be able to test our function as we make progress with it. Since this function will keep track of all unique words and count their frequencies, I'm going to call this function countWords. It's a function, so we'll need the def statement. And the input argument is going to be just simply text in this case. We agreed that using a dictionary would be a good solution for this specific task. I'm going to create an empty dictionary called word counts. The next step for us is to break the text down into words. To accomplish that, we'll be using the split method. And the character we want to use for splitting is just an empty space. This will give us a list that we can loop over. So this calls for a for loop. Because the items in the sequence or list are words, I'm going to be using word as my loop variable. So for word in text split. And now we're ready to loop. There are two possible things that can happen as we loop over our text. We can either come across a word that we've seen before, in which case we have to increase the counter associated with that word by 1. In case we see a word we haven't seen before, we have to establish that entry in the dictionary and initialize the counter to be equal to 1. So let's divide this into two subtasks. We have the case where we have a known word, and the second case is where we have an unknown word. Let's deal with the known word case first. What we'd like to test for is whether this word has appeared in this dictionary before. This calls for an if statement. If word in word counts. So now we know that we have seen this word before. What we need to do is we need to access our dictionary, word counts, and we want to increase the counter that's associated with this specific word. We want to increase that by 1. And I'm using the shorthand operation here. This is the known word case. The other situation is where we come across a previously unseen word. We can use the else statement here. In this case, we still like to access the word counts dictionary. But in this case, we have to set that counter to be equal to 1, because this is the first instance of the word that we're seeing. That deals with the second case, the unknown word. At this point, we're ready to return the dictionary to whoever called the function. We need one more statement in our code, in our function, which is the return statement. So we need to return word counts. Before we move on, let's make sure to add a docstring in our function. Now that we have defined the function, let's run it. And the function has now been defined. We also want to make sure we have our test text defined. And now we can try running the function and see what happens. And as expected, Python returns a dictionary to us where the keys are words, unique words, and the values associated with these keys are the number of times each word occurs in the text. Having some test data handy is very useful. Looking at the dictionary, one obvious shortcoming of our current routine is that it includes punctuation, like periods or full stops, as part of the word. This would lead to an inflation of the word count because, for example, a word that appears in the middle of the sentence would be counted separately from the same word if it appears at the end of a sentence and is immediately followed by a period. Another problem is that if a word appears at the beginning of a sentence, its first letter is capitalized, again giving rise to double counting of some words. To address these issues, we're first going to turn the text into lowercase. This means that any word, whether capitalized or not, will count as one word. Addressing punctuation is a bit more complex. Our strategy is to first specify all the punctuation marks that we'd like to skip, and then loop over that container and replace every occurrence of a punctuation mark with an empty string. As the first task, we need to turn the text into lowercase. We can do that using the lower method, and then we just have to recapture that new text. So we're typing text equals text.lower. The second thing we need to do is we need to define the characters that we will be skipping as we're looping over the text. We will construct a list for this purpose, and we can include a few of the most common punctuation marks here that we'd like to skip. For example, we can include period, comma, semicolon, colon, perhaps single quote, and we can also include double quote. In this case, we have to use single quotes for Python's own string. The reason we cannot use double quotes for the last string is because double quotes are also used to begin and end a string. This is why we'll be using single quotes, which surround the character that we really want to represent, which is a double quote. The next step for us is loop over all of the skip characters and replace them with an empty string. This calls for a for loop. We'll be taking our text and we will replace ch, the skip character in question, with an empty string. We then also want to capture the modified string that the replace method returns, and this part is done. Finally, to complete this modification to our function, we want to make sure to update the docstring to reflect the change we just made. We'll just say skip punctuation. Let's then run the definition of our function. And now we can try running the function using our test string that we had defined before. In this case, looking at the output, it's a dictionary as before, but you'll notice that all of the keys are lowercase, which is what we wanted. We also got rid of the punctuation marks that we included in the skips list. It's useful to be able to write your own counting routine like we just did. However, counting the frequency of objects is such a common operation that Python provides what is known as a counter tool to support rapid tallies. We first need to import it from the collections module, which provides many additional high-performance data types. The object returned by counter behaves much like a dictionary, although strictly speaking, it's a subclass of the Python dictionary object. Let's modify our function to use the counter object. In this case, I would like to retain both my original function and the one that uses the counter object. Our first step is going to be to import that. So from collections, import counter. To start the function, I'm going to take my previous function and I'm just going to copy paste it here underneath. This is the code that I'll be working with. Because this is a different function, because it's using the counter object from collections, I'm going to call this something else. I'm going to add the word fast at the end. The counting takes place in the last few lines of the code. We don't change the first part where we simply convert the text to lowercase, and we also want to keep the part that skips over punctuation characters. The only thing that will be changed is the looping over individual words in our text string. The last several lines of the code can all simply be replaced with a single expression. We will define word counts on this line, which is the first time we're using it. The input to our counter object will be the text that we would like to use for counting. We'll take our text, we'll split it to get the words, and we're done. Before we run the function, let's first do the import. We can now run the definition of the function, and then we can test it on our test dataset. In this case, again as expected, the function returns a counter object, which looks essentially identical to the dictionary object. Let's see if the objects returned by these two different functions are actually the same. We'll first call the count words function using our text. And we want to ask Python if that's equal to the object which is returned by countWordsFast on that same input. In this case, the answer is true. Therefore, we know that these two different implementations of the same function return identical objects.